In this lesson, we're going to work some problems regarding density, and the standard density formula. Density is equal to mass over volume. One thing we have to be careful of are the units of measure. So we always got to check in our problems to make sure the units match before we use density in a problem. For example, here's our first one. A square metal plate has a density of 10.2 grams per cubic centimeters and weighs 2.193 kilograms. So right away, our kilograms does not match the density value of grams per cubic centimeters. We need to convert the kilograms to grams. Well, there are 1,000 grams per kilogram, so the 2.193 kilograms ends up being 2,193 grams. Then we can do our calculation once our units match. We want to find the volume of the plate. So we know density is mass over volume. So we have 10.2 over 1, and that's equal to 2193 over volume. Cross multiply, and we're going to divide by 10.2, and our volume ends up being 215 cubic centimeters. Again, it's important to match the units. So then, there's the volume of the plate, and if we know the plate has a base area of 25 square centimeters, we're going to determine its thickness. So basically, we have the total volume, and we have the base area, and we just want to know the height. We know that volume is base area times height, so our volume is 215. Our base area is 25, and we're solving for the height. Well, you divide 215 by 25, and you end up with 8.6 centimeters. So that's a very straightforward problem. The only tricky part was converting the units. So you've got to remember to check your units before you do anything else, and do conversions to make everything the same before you move forward. So I'm going to walk through two of the more Common Core type multi-step problems that you'll need to practice. And these are all over the Regents exam, so this is a pretty big Common Core topic. So here's the first one. A contractor needs to purchase 500 bricks. The dimensions of each brick are 5.1 centimeters by 10.2 by 20.3 centimeters. And the density is 1,920 kilograms per meter cubed. So there's one issue right there. It's not matching. If the maximum capacity of the contractor's trailer is 900 kilograms, can the trailer hold the 500 bricks? Well, we need to figure out how much 500 bricks will weigh. We have the density, and we'll figure out the volume to get the mass of one brick, and then we can multiply that by 500 and compare it to the 900. The first thing we have to do is to get our dimensions to match. Density is in terms of meters cubed, so I would convert these three dimensions to meters, and then do the rest of the problem. There are 100 centimeters per every meter. So 5.1 centimeters, to convert to meters, I'm going to divide 5.1 by 100. And that's going to give me meters. So that's going to give me 0.051 meters. And then the next dimension is 10.2, and I put 1,000 there. It's supposed to be 100. 10.2 divided by 100, that's 0.102 meters. And then 20.3 divided by 100, that's going to be 0.203 meters. So now I have my brick dimensions in meters. I can then find the volume, and it's going to be length times width times height. So it's all three dimensions multiplied together. And that's going to give me, we're going to carry out several decimal places to make sure that we don't have rounding errors. 0.01056, and after that there are a few zeros. So cubic meters. That's going to be the volume. Okay, once I have that, I know density is mass over volume, and my density is 1920. I want to solve for the mass, so I'm going to end up multiplying 1920 by this very small number when I cross multiply. And when you do that, the mass of one brick ends up being 2.03 kilograms. Okay? That's for one brick. So now I want to figure out how much 500 of those bricks weigh. Well, 2.03 times 500, and that's going to be 1,015 kilograms. So if I compare that to the 900 kilograms, the answer is no. And all my work kind of shows my justification. The bricks will be too heavy. And they're going to be too heavy by about 115 kilograms. So that's the type of multi-step problem you're expected to do. You take volume, you first settle the dimensions, and then you're going to do some kind of density calculation and use that answer to further calculate some other either capacity or some kind of cost analysis, something like that. So it's not going to be just a density calculation problem. There's going to be several steps to these things. So we're going to cover one more in here to show you all the different steps that you're expected to do. Alright, trees that are cut down and stripped of their branches for timber are approximately cylindrical. So we're going to model this tree using a circular cylinder, and it has a diameter of 50 centimeters. Okay, and it has a height of 10 meters. So right there, you've got to pay attention to this. I have a height in meters and I have a diameter in centimeters. So let's see what the density is in. So typical diameter 50, height of 10 meters. The density is 380 kilograms per cubic meter. So we're going to want to convert to meters. 380 kilograms per cubic meters. And then the wood can be sold by mass at a rate of $4.75 per kilogram. And we want to know the minimum number of trees to raise at least $50,000. So we need the volume of one tree, and then we'll use that volume to calculate how much one tree weighs, and then we'll get the cost or how much money is generated per tree, and then figure out how many trees we need to make $50,000. Alright, so the 50 centimeters is the first issue. I need to convert 50 centimeters to meters. So again, we're going to divide by 100, and that's going to be 0.5. Now that's the diameter. So if I want to calculate volume, I need the base area. That's going to be pi times the radius squared and then multiplied by the height. So if this is the diameter, the radius is going to be half that. So there's all these little steps you got to be careful of. Alright, so the volume calculation, pi times 0.25 times let me fix that, 0.25 squared times 10. Everything is in meters, so my units are good. And when I calculate that volume, I get approximately 1.9635 cubic meters. Alright, I take that answer, I put it into my density problem. So the density is 380. That's equal to mass over volume, which is 1.9635. Cross multiply, and you get a mass value of one tree to be 746.13 kilograms. So we're going to take this out a couple of decimal places just to make sure we don't have a rounding issue at the end. Okay, so now we can find the cost of one tree. I take my mass, 746.13 kilograms, and this is 475 per kilogram. So one tree is going to be about 3,500 and some change. 35.44 and 12 cents. All right, almost done. So now I want to raise $50,000. So we're going to figure out how many trees that's going to be. If I divide by 3544.12, I get approximately 14.1 tree. Okay, so here's where you have to be careful. I want to know the minimum number of whole trees that I got to sell to raise at least $50,000. This is telling me if I raise and sell 14 trees, I'm not going to have $50,000. I'm going to have slightly less than $50,000. So since this is 14.1, we got to jump up to the nearest whole tree, and that's going to be 15. And you can double check. Take 15 and multiply by 475 and see what you get. Or 15 and multiply by 3544.12 and see what you get. And that'll be above 50, whereas the 14 is going to be slightly less than 50. So these are the types of problems that you're going to be expected to do on the Regents exam. They're multi-step. Each step isn't bad, but again, the first thing you do is you compare your units, make sure all the units match, do all your conversions, and then read carefully. If it's circular and you have a diameter, you got to convert to a radius, and then use the volume formula, and then use that in the density formula to get the mass, and then from there you do whatever you need to do with the mass. In this case, it was to find out how much it costs. In the previous example, it was to figure out how many bricks would fit on the trailer, etc. So they're kind of this similar problems with the same number of steps. And then at the end, just make sure you answer the question correctly. If I'm raising at least $50,000, then 14 trees are not going to cut it. I'm going to need 15 trees. And we will work some more of these problems in class.